Welcome. Thank you for joining us for our webinar, The State of Open Source Software 2016 Year in Review. I am Nicole Marino, Product Marketing Manager at Flexera Software, and it's my pleasure to moderate today's webinar. Before we get started, let me point out that you can ask a question at any time during the event via the chat window you see on your screen, and we'll answer them at the end of the presentation. Also, this meeting is being recorded, and each of you will receive a link to the recording and a PDF of the slides within a few days, and it will be available on our website as well. Let's get started. I'd like to introduce our speaker today, Jeff Luszcz. Jeff is the VP of Product Management responsible for Flexera Software's Software Compliance Analysis Solutions. Previously, Jeff was founder and CTO of Palamita, a leading provider of open source discovery and vulnerability management solutions. Jeff also led the team responsible for OSS compliance and security audits and performed reviews for some of the largest mergers and acquisitions in the technology industry. Prior to Palamita, Jeff spent 6 years at Mass Ames Research Center, where he implemented software for simulation of flat panel display technology and the related human factor. So today, Jeff will be walking us through open source software usage trends and how it's affecting companies, resiliency and the lack of it, including examples of well-known malware attacks, the state of compliance, and what's coming in open source this year. So with that, let me hand it over to you, Jeff.
Thanks so much. Thank you for that introduction. Let's first talk about open source usage trends. It's been in the news very much lately about how much open source is out there and how prevalent it is in our ecosystem. And one of the nice things that we've been able to see at Flexera over the last 12, 13 years is how much open source usage has changed. If you looked back in 2011, when we first started keeping these records, the typical open source project would use about 135 open source items. Same thing for a commercial project. If you were a commercial entity and you were creating software and you looked internally, the expectation is you would find on the order of about 135 open source libraries inside your product. Of those, you would only be aware of 18. We call that the disclosure rate. So you knew about 18, but in fact you were using 135. And that would give you a disclosure rate of about 13%. And this is a metric that we have used over the years to keep track of how much understanding we think that the commercial world has of the open source usage, what the best practices are, and are they being followed. And our developers basically keeping track of the open source that they're using. And you can see as the years goes on that more and more open source is being found inside of commercial products. Every year we see another 20, another 50, another 75. So from 2011, where we see an average of 135 software libraries and software components being used, all the way to last year, 2016, with the average project that we reviewed had around 560 open source libraries, also known as components inside of it. But if you look at the disclosure rate, it hasn't changed much since 2011. Typical company would only be aware of about 27 items in their software bill of materials. And that's a disclosure rate of 4%. And I think that's kind of amazing that over the last 5, 6 years or so, we've actually gone down in our understanding of the open source usage that's going on inside of our organizations, while the amount of open source we're using has really exploded. Let's go to the next slide and talk about why this happened. So why do we see more open source when we look at these packages, when we look at these commercial projects that are being built and used? Well, first off, there is a true increase in more open source usage, also known as OSS, open source software. Well, a couple reasons for that. First off is that executives and vice presidents and the people running the companies have definitely loosened any restrictions that were in place. So previously you would talk to a VP of engineering or a CTO or a CEO and they'd say, we take open source only very carefully, it's only when we can't do it ourselves, et cetera, et cetera. And now it's really flipped around where they say open source is our best practice. There is so much great open source software, there's so much great software components that are out there, we would not be smart to restrict the use of open source in general. So developers have heard that. Let's use more open source. It's more than acceptable. It's expected. We're also seeing larger and more complex systems in use. So maybe 5-10 years ago, you might have had a single executable. You might have had a single web app. But now we're seeing things like large embedded systems like we see in automotive. We're seeing complex operating systems being used in devices like IoT, or large coordinated systems if you're doing a SaaS project where you have databases and front ends and back ends and data processing. And it's not just a single app anymore, it's a coordinated system of applications. We're also seeing a lot more smaller packages being used. So the jQuery ecosystem in the front end world, NPM modules, these node modules on the back end. Where previously you might have had a large monolithic library that brought in many services, now it's been broken up into maybe 70, 100, 300 modules that perform that same task that one large Uber library used to provide 5-10 years ago. We also see the use of package managers. So you might be familiar with things such as Maven or Node Package Manager again, or NuGet. These are all ways that developers can basically record the open source libraries that they want to use and have these package managers basically download these libraries at build time. And it's become very easy to, much like a menu, say, I want this, and this. Bring those libraries in, plus their dependencies. And that can greatly increase the number of packages that get brought in, even from a single request. We also see containers and custom Linux distributions are definitely increasing. And the more custom your operating system is, especially in the Linux world, the more compliance tasks and disclosures you're required to basically perform. And this is extremely important in automotive and IoT, and we'll talk a little bit about that later on in the deck. So all of these trends, and I'm sure many more, have caused developers to use a lot more open source in the last 5 or 10 years. And that trend is just going to increase year after year. So I expect next year we will crack 600, 700 items as a expected value for the number of open source libraries in your typical project. We also see that there's been an increase in analysis, meaning the expectations around compliance and disclosures have increased. One reason is that the level of expected analysis has increased. So we live in a web of trust. We live in a software supply chain. And we definitely see the next people in the chain, whether it's customers, whether it's larger organizations, whether it is open source organizations who are expecting compliance, they've raised the bar. It's not, you just can't simply say, oh, we're using a single license or we're using Linux, and have people expect that that's a good enough disclosure or good enough compliance. So we're seeing this written into contracts. We're seeing legal teams and development teams set from the very beginning of their expectations about what level of diligence and disclosures need to be performed. There'll be a right place in the manual and the about box. So that the expectation has increased. We also see that there's more awareness of your dependencies. So when you're creating a SaaS project or another application and you say, you know, we do have a dependency on a database and a queue and a web server and an embedded OS and this and that and so on, that previously those would not have been disclosed as dependencies, even though they're there, even though they're shipped. Sometimes because they're handled by different teams. Sometimes people just consider them part of Linux or the operating system they're using. And we see that this awareness of not just app-centric disclosure, but system-level disclosure has increased. Also say that the legal teams have been able to handle more as they've educated themselves on what licenses mean, what their policies are, some of the more sticky situations about how do you handle linking, how do you handle cutting and pasting, how do you handle snippets without origin, all these things that can take some time to understand as a legal team. We're seeing that there's many teams now have had 5, 10, even longer years of experience under their belt, and they're able to say, give us more disclosures. You know, we know that they're there. Please give it to us. We're able to handle these things. We're able to handle subcomponents and so on. That's a very important change in the industry. We also see a lot of technical due diligence process on M&A, where previously people just say, oh, give me some disclosure documents, give me an architecture diagram, let's go have a nice dinner with the CTO or the CEO. Well, the expectation before these projects are brought in now at acquisition time is to do a deep dive and see what's going on, make sure that there's compliance, make sure there's security reviews and so on. Linux and deep analysis is, again, very important. And the commercial supply chain is not as trusted as it previously was. Heartbleed, which we'll talk about in a little bit, was a big driver here, some compliance issues that have come up, as well as just people looking inside of these packages themselves and saying, I'm not seeing this open source that I'm getting from my commercial supplier on their disclosure list, and pushing back on that. Security was a big pushback, as well as licensing. Both of these trends, these sets of trends together, show more open source in the due diligence, in the bill of materials, partly because of more usage, partly because the expectations around disclosures have increased. So I talked a little bit about Heartbleed before. This occurred back in April of 2014, and it was a kind of an acutely named vulnerability. Open source and commercial libraries and packages have vulnerabilities every day. This is part of writing software. They're going to have security problems that are discovered sometimes years after they were introduced into the product. One of the nice things about open source is that you have access to the source code. You can change it. You can modify it. You can put it, do tests with it to figure out how to break into it. So that gives us some really good value around staying secure, basically clearing out vulnerabilities. Well, but sometimes one of the problems is that a vulnerability that is discovered has a very large impact on the industry because we're all using the same library. And Heartbleed, I'm sure many of you on the call today remember just what a big deal this was. It touched everyone's product. Nobody knew where it was. It really opened people's eyes to how much open source they were using and how difficult it was for them to manage it and discover it, as well as how it was impacting their software supply chain, both in the code that they received from their vendors, as well as the code and applications that they passed down the line as their role as a member of the software supply chain. And what we've seen from this is that these types of vulnerabilities, vulnerabilities in general, have very long tails. There was a lot of heat and light that first couple of weeks around Heartbleed. Everybody was staying up late. Every CEO was saying, get me this report in the morning about what our impact is and what our plan is for fixing this. And I think a lot of the industry felt, oh, we've cleaned this up. We much like Y2K, we saw a big problem, we fixed it, and we've moved on, and we've learned a lot from it. Well, what I would say is it's not quite right. We did a lot of remediation and fixing of high impact and high value projects, infrastructure pieces, et cetera. But when it comes to, did we clean up the industry? Did the industry really learn a lesson from this? I would say it's a resounding no. We still find versions of OpenSSL, that's the cryptographic library that was affected by this named vulnerability, that is still vulnerable to Heartbleed. That's now almost over 2 years after it was discovered and remediated in much in the industry. We still find shipping products that are shipping the very version of OpenSSL that was called Heartbleed, affected by this vulnerability. And what this tells us is that many organizations did not look everywhere. There were places where OpenSSL usage was hidden. There were places where maybe it was fixed once, but then they reverted due to some sort of engineering fix that maybe brought in old versions and overlaid the patches and so on and so on. And what this tells us is that it's going to have a very long tail. We just can't believe that we fix something and put it behind us. We always have to be vigilant, especially for these very popular and very well-named vulnerabilities. We call those stale components, zombie components, basically things that have lived much longer than people expected them to. And they occur in some very common places. So obviously, unexamined code bases, all types. If you never looked for Heartbleed in older versions, if you never looked at it in patch releases, you didn't fix it yourself. If you received compiled binary versions of libraries, maybe from your vendors, maybe from like a repository manager like NuGet, if you didn't look inside of that and you didn't patch and upgrade it as the component vendor discovered problems, you're still going to have that old vulnerable version of whatever the impacted library is. You may be getting precompiled open source from your Linux operating system. Again, a very common thing where development organizations create their own operating system, they create their own fork of Linux, and they don't have patch management in place. They don't have vulnerability feeds coming in and upgrading those libraries. They basically made a fork of Linux, and then they're responsible for all the management. We see a lot of cases where things like OpenSSL and other vulnerabilities just sit there and basically wait to be exploited. Larger source organizations as well, so you bring in a large library in source form, and maybe you're only looking at the top level name on the library and say, well, it has nothing to do with OpenSSL. But buried deep inside of it is what we call a subcomponent. Again, a great place to find these libraries, as well as things such as stale containers or old virtual machines. So when people fire up a virtual machine running a library or a container running an old library as part of the heart of the system, it's very common for these things to have a very long lifetime and not be examined for these types of vulnerabilities. So these are things that you should expect are probably running in your organization right now. You might have hit the marquee projects. You might have hit the item in current development and maybe the last item deployed. But there is probably instances of these types of well-known vulnerabilities still running in your organization, especially if you're of any size. One of the good things I think about this is it has definitely opened people's eyes. There's many cases where people say, I'm not shipping a product, or we're in an embedded industry and nobody's really checking us out. We're okay from compliance. We're okay from vulnerability. We have a security team. I'm sure they're watching out for this. Heartbleed and Drown and Ghost, and there's a couple very well-known vulnerabilities in a very short time that opened people's eyes. They said, we don't have a handle on this. We're using a lot more open source than we expected. We're not patching things when they need it. We're not doing the right disclosures. We're kind of not doing the right thing on the compliance side, and we're not doing the right thing on the security and vulnerability side, and we have to do a better job. And it takes a while for organizations to change how they do things, especially how they build software. But I've been seeing some very good movement in the industry, especially in the last year, around vulnerability management, around proper disclosures, and setting expectations with the developers about what is expected out of compliance and vulnerability management. One thing that organizations will start doing is they can't boil the ocean. They want to get compliant. They want to get rid of as many vulnerabilities as they can. There's often a case. What they'll do is they'll do a health check. They'll what I call indicator species. Basically, if these libraries are in use, these versions of libraries are still being used, it's a pretty good sign that you're going to have a lot of vulnerabilities in your code base, because these are the first things that people will look for to see if you're currently on task with keeping your versions upgraded. Are you staying away from known hot button vulnerabilities, whether it's named vulnerabilities or just things that people know that you have to upgrade. And these are some things that I find has been very helpful. Some of these are relatively new, some of these are relatively old, but you will see these in a code base and get a good feeling right away about is the development team, is the security team keeping on top of things. So we don't have to read through all of these, but they'll be in the slide notes and the background here. But basically looking at some of the very common open source that's out there: jQuery, Prototype, OpenSSL, zlib, Tomcat. These are libraries that almost certainly you're going to encounter in a large organization. Almost certainly you're going to discover these in your web app. And by looking at those versions, by looking at both in source and binary form, if you encounter these things, especially things like old OpenSSL, old zlib, these are great indicator species where you can point to and say, if we didn't get this OpenSSL version right, if we didn't get this zlib version right, how can we trust that we've done the right thing for any of the other less well-known open source projects? So how are large companies setting the standards? Very often people do what's asked of them. So when we look at the software supply chain, if we look at both small and large organizations, and very often large organizations are able to set the standard. They do this because they have a long history. Maybe they're public and they have the ability to both have internal audit teams, internal compliance teams, as well as maybe the board of directors is hammering on them saying, do you understand we're a big company? You understand there's a lot of eyes on this. We need to be doing the right thing in everything we do, whether it's software or pick another task that we do, finances, et cetera. We have to do the right thing. And as they see that they have a hole around compliance and vulnerability management, they start to set the standards. Well, one thing that they've noticed is that the disclosures are just not trustworthy. If you're a large company doing acquisitions and you say, tell us about all the open source and commercial code you know, and you get a list of 15 items back, you know that you just can't trust it. And if you get one, you know, as our previous data showed, that you could probably times it by 20 or 40 to get a feeling for what your true dependency on open source and commercial items are. And even if you get a large, long report, odds are it's auto-generated, meaning someone got a request that please go give us a disclosure list. They went very quickly, generated some report, sent it over to the person asking for it, maybe an outside company, maybe a partner. But odds are that list has never been reviewed by the legal team. It's never been reviewed by an open source review board. Odds are first time anybody's ever looked at it is when it was generated. That's the expectation in many companies when they see something, even if it's a pretty big bill of materials coming out. The technical debt around open source and third-party usage is now starting to cause some problems. We're seeing some grandfathered code that has vulnerabilities, so it's been out there for many years. The team is not around to patch it anymore. Organizations saying, well, let's get a couple more years of revenue out of this and we'll have our next generation product ready to take over. That might have been okay from a compliance perspective, but as vulnerabilities age out, as products become vulnerable as these libraries are discovered to have vulnerabilities, you just can't wait and see as much as you could many years ago. You also see cases where code comes in and it's maybe reviewed lightly or never reviewed, but it's been grandfathered in. Oh, it must be okay because it's been there for 5 years or 10 years. It's never caused us any problems. We've seen some very important, I would say, marquee security problems in the last year from code that probably had that happen to it, which is, oh, we've always used it. It's always been fine. Legal signed off on the license. We're good. Nobody ever went back to look at it for vulnerabilities, and these things age out over a year, 3 years, 5 years, 7 years, 10 years. And this is almost certainly the things that you need to look at first, which is what is our oldest code? What's still in use? Have we looked at this for known vulnerabilities, especially for some of those indicator species? We also see where people are forking open source projects. They say, well, I need to fix this because of my security standards or my legal standards, or just we're removing certain features to make something more secure. We've now forked it. It's basically, it's your, we sometimes joke that this is your puppy now. You are required for all the care and feeding of this fork now. And this is causing some management problems. Large companies did this for 1 item, 2 items, 3 libraries. Now they're starting to see dozens, sometimes even hundreds of libraries that they forked for those reasons. And they're starting to look and say, what can we do to maybe push these things back to the open source projects? How do we support these open source projects so we can have good quality, good compliance, good feature sets that are appropriate for our organization, but also appropriate for everybody else? And there's going to be some tension there because not everybody has the same needs or feature sets. But that is something I'm starting to see where organizations are saying we just can't have dozens, hundreds of open source forks anymore when we need to manage it ourselves. We are seeing more notices expected. I've definitely noticed more and more about boxes and documentation having what I would consider a much realistic list of open source disclosures there. Still not perfect by far, but it's becoming a common expectation that there will be, especially from well-known organizations, that there was going to be disclosures of some sort. And we have seen, especially in the last year, the expectation that if you're using certain licenses like the GPL, the general public license, or the LGPL, the lesser general public license, that you will provide the expected source code to the people who are owed it. And that is, especially in automotive, has caused some hot button issues in the last year or so, where companies have been asked for these source bundles and we're not quite ready in milliseconds to return it, and when the community expected much quicker compliance with that ask. So if you are involved with Linux, if you're involved with automotive, IoT, if you're distributing a Linux distribution, that should be one of the top of mind things for you, which is how are you going to provide the source code to your customers, the people who ask for it. So these are things that are some trends I'm seeing in larger organizations. I see them start to set the expectations with their vendors and smaller companies around them. People who are looking to get acquired by these large organizations are following this lead. And I expect to see this list in the next year become even longer as there's more regimented tasks put in front of the supply chain, expectations around co-selling and things like that. So let's talk about resiliency and the lack of it. I think this was a really great year in terms of how software vulnerabilities can affect the whole world. So almost certainly everybody remembers what happened in October. October 16th of this year, there was a attack, basically a distributed denial of service attack on things such as the Dyn company, which was a DNS supplier, basically a name supplier for the internet lookup service. Well, it was only tens of thousands of IoT devices. It could have been much larger. And it basically was able to take this company down, and as a side effect, it was able to basically remove access for many people for things like Twitter, GitHub, Amazon, Netflix, etc. And at the heart of this was basically this malware that was able to, the Mirai malware, which is able to infect IoT devices, specifically surveillance cameras. So basically there are thousands, hundreds of thousands, millions of these IP-enabled surveillance cameras that are out there running. And basically, so people want to look at their laundromat, they want to look at their shop floor, their backyard, etc. Well, the problem is they had some problems. They had some default passwords. Some people say 61. I'm sure there's more now. They're always improving the botnet. And this basically, this malware was able to crawl the internet looking for these devices, try a list of known passwords. Once that worked, they were able to put their payload in and then be able to use this botnet as basically a coordinated attack on whatever they wanted to do. And this what I thought was very interesting because it was a pretty simple attack. It was embedded passwords. It wasn't even taking advantage of known software vulnerabilities yet. The fruit was so low hanging that they just had to look and say, what's the most easy attack on this? And I think that really just shows how these products are being designed right now. They really have not thought about, in many cases, the problems with coordinated attacks, the problems with what happens if 100,000 or 1 million devices all get attacked with the same malware. How do we defend about that? How do we make our network more resilient? How can our companies detect that this is even happening on our own networks? Since that, there's been some discussions around some other malwares that are out there that are using, I would say, more interesting attacks. You don't need an interesting attack. You don't need an interesting attack. But as things such as the known passwords get closed down, these botnet creators almost certainly going to start looking for things like this. So Bashlight is been out there since 2014, for a couple of years, and what it does is it targets multiple operating systems as from both open source and commercial vulnerabilities. So what bugs exist? And let's try this one. Let's try this one. Let's try this one. Let's try. This one works. We now can infect this device with our malware. And as of August 2016, the reports are there's been over 1 million infected devices, mostly cameras, but some others as well. And many of these devices share the same innards, basically the same chipset and boards inside, which is one of the things that we've seen in the software supply chain and the hardware supply chain is just because the outside of a device or a product has somebody's name on it, somebody's label, sometimes it's just a rebranded something else. And so this is something that we see when people start asking questions about their hardware supply chain and their software supply chain is where did the heart of the system come from? Are there things hidden behind a commercial name? Should we ask more questions? Give us your disclosure list. And somewhat related but unrelated, this is not malware, this is not any sort of infection or anything like that, but this is showing in some ways the lack of resiliency that we're still trying to fix in our industry. So back in March of 2016, there was an open source library called LeftPad. It was only 11 lines long. And there was a trademark issue. This was basically an intellectual property discussion about, do we own this name? Do you own this name? And the developer basically said, I'm gonna take this off the net. I'm done. I'm gonna remove this. And so by removing this library, they removed all their components, and they took about 273 components off the network. They said, I'm gonna do something else with my time. And one of those components was a thing called LeftPad, and it had a cascading effect. So this library disappeared. The other libraries that depended on it at build time started to break, and this cascading effect really caused some problems. And the organization behind the NPM, this repository, really had to scramble to make things work again. And this was very eye-opening for folks because, again, it showed them how much dependency on open source they were using. Even if the developers were not talking to the management about how much they were using and how they were doing all the right disclosures, the fact that the build broke, the fact that there had to be this scramble, and at the heart of it was around this 11-line library. Again, we look at these events that open people's eyes and they say, what is our plan for dealing with this? What is our plan for dealing with this other thing? What else are we doing that might be affected by a similar type of whether it's an attack like in the botnet world, or a kind of a business event like somebody saying, I'm going to just delete my components for whatever reason. So let's bring this to the state of compliance. So there are things that are going on out there that may be affecting our use of open source, or some things that are affecting our business continuity, affecting our ability to patch things and patch problems as either we find out about it or somebody else tells us about it. So let's talk about the state of compliance. So there's some great organizations that are out there that are kind of encouraging compliance, helping with compliance, both on the open source side and the commercial side. And there's just some names that I think you should be familiar with. One of them is the Software Freedom Conservancy. These are some great folks who are very passionate about open source. They want to provide a great organization and a mechanism where open source teams can basically work together to get infrastructure in place, which is things such as sponsorship, basically things like the infrastructure that is required in order to run an open source project. Have the developers do what they do best, which is perhaps writing technology and creating technology, but provide basically an umbrella around working together, sharing information, as well as getting some of the infrastructure things handled. And there's some really great folks over there who do that. They also help with compliance. And so basically, if you look at some of the organization, what they've done, if you go look at OSCON in October of 2016, they gave a really great talk around the state of a look at the enforcement worldwide and what's going on out there. Karen Sandler did a great job talking about what's going on, what legal actions are going on, what can you do to help basically stay compliant. And I think it's a good talk, and I'd recommend taking a look at it. But it also shows who is out there who is both helping organizations remain compliant, but also kind of encouraging and enforcing compliance. You're not doing the right thing around open source. You may get a call from, say, like the Software Freedom Conservancy. I would take that very seriously, definitely work with them, and look at your processes that are in place to help make sure that you are doing the right thing. You never want to get a phone call. You never want to get basically notice that you're not doing the right thing with open source. They provide some great documentation about how to keep yourself compliant. Again, I strongly recommend taking a look at that. There's also some other organizations out there. One that was doing some work for many years, and I think is coming back again, is one called GPLviolations.org. And again, this is a community here who looks at companies and products and maybe you're not doing the right thing around the general public license. So again, another organization to be aware of. Go take a look at their website. Again, if you get a notice from them, treat it very seriously. It's basically you want to make sure that you're doing the right thing around the open source licensing. I would say especially the general public license. There's some great guidelines that are out there about what to do. Also, I would look at what organizations have done that has not been compliant in the past and just use those as best practices of things not to do. So what organizations have had letters and notices from folks like the GPLviolations.org in the past? And if you are in similar spaces, you may be making the same mistakes that those other organizations did as well. Use those as guidelines to help get yourself in better compliance state. Let's talk a little bit what I think is going to be happening over the next year here in 2017 around open source usage and trends. Well, things that you should be looking at. First thing, project sizes get larger and larger and larger with every year. If we go back 10 years, a large project was about 10,000 files. It is now extremely common to see a project have 500,000 files inside of it, 500,000 files. And coming across a project that's over 1 million files is not an anomaly. It's very common, especially when we start talking about automotive, when we start talking about coordinated SaaS systems, when we start talking about multiple basically pieces, both front end and back end of large systems that are out there. 1 million files is just not uncommon anymore. You also see that the SaaS teams, in many cases, are doing what we call gluing, not coding. So they're going out and they're grabbing open source libraries one after another after another. I need another feature, I'm going to pull in a library. Why write an XML processor when there's amazing open source libraries out there that's going to do a great job for you? Well, you now see hundreds to sometimes thousands of libraries, many maybe that have low line count, but taken together can add up to very large libraries, a very large library size. You will see that embedded in IoT is still doing what we'd call traditional development, so kind of lovingly hand carrying a library from one place to another and moving it here and moving it there and taking a file here and snippets from there. And that is something that can make compliance difficult, because there's not these repository managers who may be labeling the libraries here and there. You're seeing a lot more kind of a cut and paste development, which can make it almost impossible for organizations, if they're not tracking it from the very beginning, to stay on top of compliance and vulnerability management there. The repository managers, as we said before, are just bringing in incredible amounts of open source libraries. And you will see this both in the open source libraries that you're bringing in yourself, as well as the software supply chain that you're inheriting or purchasing from commercial companies. So be aware of both of those locations when you start looking at the libraries that you're using. And look at the ecosystems that you're participating in. If you're in Java, you're probably using Maven. If you're in Ruby, you're probably using Ruby Gems, and so on and so on. These should be names that you're very familiar with. If you're involved with technical management or development or legal at all, if you're not familiar with the repository managers, you're probably missing a lot of the open source that you're using. And I would say also, if you are using or creating SDK, it's becoming more and more expected that people are going to dive deep into these. They used to just be treated as a single line item commercial SDK. But now, especially in the embedded space, the board support package space, if someone's giving you an SDK, expectations can be full of open source, and it's not usually as well disclosed as it should be. And especially if you're doing any Linux development, there's very often kernel drivers there and other drivers that are under the general public license, which is a great license. But your developers need to know that even though it's coming from a commercial organization, many of those packages may be licensed under the GPL. And that's been a big source of confusion I have seen for folks doing automotive and IoT and other embedded work, where they come across something and say, hey, we've obviously purchased a license, we're paying money for this embedded piece of hardware, but the driver itself is under a general public license, a very free copyleft license that requires a different type of compliance than, say, commercial compliance. Okay. One of the last slides here. What else is going on? Well, unlicensed code is still a legal challenge. We see significant amounts of code that is freely available but does not have a license, meaning there's no open source license embedded in it, there's no commercial license embedded in it or associated with it. Sometimes if you even go ask the developer of this, they say, I don't know. What license do you want? I don't know if I need a license. Well, you pretty much need a license to use somebody else's code. That's basically the only way you get permission to use somebody else's code. A commercial license or an open source license, that's something that you need. And especially for large and medium companies, medium-sized companies, we see this be an issue because they come in and they say, we know we need a license and we don't have a license for this. Now what do we do? Maybe they go approach the developer and ask for a license. Maybe they delete and destroy the code that's affected by it and try it again. There's many mechanisms for dealing with it, but you just have to be aware of it. And if you are somebody who's going to be selling to large or medium-sized organizations, you should just be aware from the very beginning that this is going to end up being a problem. There's a great website out there called Stack Overflow. It's a really useful question and answer site. Developers will ask questions or search for questions and get answers there. One of the issues, though, is they had a license that was very difficult for organizations to deal with for many years. It was a viral license. It was called a Creative Commons Share-alike license. And it was difficult for companies, especially if they were doing a good level of compliance, for them to use these answers, the code that was coming from these answers, and be able to respect this license. And so recently Stack Overflow changed their license to an MIT-style license, so more of a permissive style license. So there is still this long tail of older code that is maybe even the lion's share of the code that's available on Stack Overflow that's under this share-alike license. This is something that people are dealing with. They see the references, they see the code, and just how do you handle that? Is there ways of, again, asking the original author to give a new license, or do you refactor the code, or how do you handle this? That is something almost certainly you will encounter when you start looking in your code. If you're not familiar with Stack Overflow already, as a legal or technical person, you should be, because almost certainly you are using multiple instances of code that has come via this organization. Oracle is definitely number one company, commercial concern, in the sense of people saying, if we're using Oracle code, we want to be aware of it. We don't want to have a surprise in terms of licensing fees. We don't want to be shipping somebody's commercial code without paying for it. And Oracle is definitely an organization who is widely used out there in the industry. It seems like many people are using their databases and other technologies, Java technologies. But companies just want to be mindful, especially if they're doing things that are maybe a little bit out of the ordinary, or they're using the Oracle technologies in ways that are going to require special licensing fees. Again, people want to be very mindful about that usage and just be aware of where that code is coming from. We are definitely seeing more source analysis of key open source binary libraries. So if something's coming in through a repository, people really want to know what's going on inside of there. Or if they've received a binary blob from a commercial vendor and they see that there is open source inside of there with no disclosure or a very small disclosure, they're doing some of the analysis themselves and then pushing back to their supply chain and saying, you need to do a better job. I did a little bit of this for you because I need to know what's going on, but I found enough to tell me that you're not doing a good job in terms of being my supply chain vendor. So do expect that, and it's not a bad thing to do if you are involved in supply chain and you're receiving binary files from somebody else to do some quick analysis, see what's going on. A couple last points here. If you're using multimedia libraries, so anything that shows audio or video, again, it's a big deal for organizations who are doing that. There may be some patent royalties owed for usages of certain parts of those technology. That could be a surprise to people. They thought they were using something that was pure open source and didn't realize that there perhaps were some patent issues involved. So anything dealing with multimedia, again, is something that we think always requires an extra set of eyes on. If there's certain libraries like FFmpeg that are being used, great libraries, everybody loves them, but they are often indicators that you're using certain technologies that may have some additional intellectual property rights, like patent rights and things like that on top of that. You should just be mindful of. People are still not doing a great job around copyright attributions and license disclosures, especially for things that are not kind of the hot button licenses. So people seem to try. They want to get the GPL license compliance right. They want to get the LGPL compliance right. They're not doing a great job of it right now, but that's at least on their radar. But for things that are, say, MIT license, BSD license, Apache license, organizations, I would still say, are not doing great jobs of knowing what libraries they're using, fulfilling the license text and copyright text obligations of the various licenses. And it's something that you should just expect. You might see your license disclosure skew toward the kind of priority one style licenses, the copyleft style licenses, but just know that there may be a long tail of MIT, BSD, Apache licenses that you're just not aware of. And we always like to add this, is I still have yet to see a company, I've now been doing this for over 13 years, I've yet to see a company get to full compliance right away. It's something that's still a line on the horizon. I've seen some companies have done amazing jobs, but still have some troubles getting to full compliance. And the vast majority of what I see is that 4% disclosure rate, meaning there's some key items that have been disclosed, but the vast majority of the open source that they're using is just unmanaged. You will be hearing much more about IoT and hardware and embedded in the next few years here for sure. Just as there's more devices, cheaper devices, especially being deployed at scale. So one of the things I think will be affecting the trends over the next couple of years here is how hardware and cheap IoT devices or even expensive IoT devices are being used and what they're being built around. And so hardware has always been one of the main focuses of GPL compliance because very often these things are built around Linux. And especially things that are white labeled or have a chunk of plastic around them or scattered around the world, they're not always doing a great job around compliance. They're not saying, oh, we're using Linux, oh, we're using BusyBox, oh, we're doing all these things here. So do keep that in mind. One of the little tricks I will always say is if it has a radio in it, like a Wi-Fi radio or Bluetooth, or it has an Ethernet port on it or a power port on it or a battery, you should be very mindful that you are likely using Linux or some other embedded operating system. And that is not always disclosed by the developers. It's not always tracked. So look around for things. Look for, how do you boot? Are you using this great library called BusyBox? It's very commonly used, but it's not always respected in terms of compliance and disclosures. We see a lot of things such as home-rolled Linux distributions being very difficult to have compliance on and very low disclosure rates. Automotive distributions, anything else like that you have a device that's embedded, that's running Linux. You may have multiple devices, 11 Linux machines in a car or a robot is not uncommon. And each of those devices may be running a different version of Linux because they were created by different teams. And we're definitely seeing more pressure on the chip and system-on-a-chip manufacturers to say, please help us with compliance. If you're selling us a chip, you're giving us a bunch of software, including Linux, we do expect you to give us good disclosures, give us good license listings, because we're going to have to do it ourselves. If we ship this device, if we sell this device, we're going to have to do that right compliance. I'm going to use this to pick the right chip vendor who helps me the most with my compliance task. In terms of IoT, we are definitely starting to see a leading edge of IoT-related audits and customers. IoT has been in the news a lot, and now we're seeing people starting to say, I want to know what's going on. What's going on inside of my device? What's going on inside of my coordination system? We're starting to see a lot of cheap devices, $2, $1.50, with no or little open source compliance inside of that. And $2 does not buy you a lot of security compliance. Doesn't buy you a lot of open source compliance. So we're seeing pressure on these devices as well from organizations, especially post Mirai botnet and post some of these legal cases in Europe around being responsible for what you're shipping. And that's making it further, going higher and higher up the stack of management. It says, yes, we are aware that we are responsible for this, and we got to bake this into our contracts and our vendors. And one thing that we do see in IoT is because the devices are very small, they don't have a lot of memory, they don't have a lot of disk footprint, storage footprint, that we're seeing a lot of single files being ripped out of larger open source packages, single routines, cut and paste, with very little attention being paid to license. The developer's main task, it seems, is to make the features work, make the functionality work, through almost any means possible. And many of the packages get lost through cutting and pasting. And that's going to be, I think, a big deal as people start to look at a lower level here, as they start to have higher expectations around disclosures and security upgrades. If you've cut and pasted the crypto routine from one library and you've lost the copyright statements and you've lost the file names, how do you know if you've patched it or not unless you've kept track of it from the very beginning? So very important thing to do, and it's a good best practice to help your developers understand. Okay. And at that point, because of time, I'm going to skip right to the questions here. I see there's a couple, I keep a couple questions here. The first one is, we have a security team. Why wouldn't they manage this? And I think that's a great question. And I would say the security team is starting to manage this. This is something I think that was not in their visibility and their worldview until possibly even Heartbleed. There were some organizations, especially those like in the networking world, who they've always tried to keep track of their packages. They've always tried to stay on top of the vulnerabilities that were there, but they didn't always have visibility into what was going on inside of the source tree, inside of the development organization. So they might be keeping track of the operating system that is being used or deployed. They might be keeping track of devices that are out there. They might be doing things like penetration testing and running automated scans on the deployed devices or the deployed applications. Or they might be running some security scanning software in the proprietary pieces, but they would miss or route around the open source pieces because maybe it was too big of a problem, or maybe those things were hidden, or they were in binary form only. I would say this is becoming more in the purview of security teams, especially as they get awareness to new attacks that are going on and the complexities of how software is being developed. But I will still say there's some silos. Development organizations very often are seen as being responsible for the code that they put in, and that includes the open source and commercial code. Well, very often security teams may be more responsible for things such as deploy code, pen testing, things like that. That's not always true, but that is a divide that I often see in organizations. Second question here is, we keep hearing about SSL, OpenSSL in the news. Should companies be more concerned about this? And I think one of the reasons we see OpenSSL in the news so much is because it is such a widely used library. So just because you hear something in the news a lot does not mean it's bad. What it means is it's popular, and it's a great topic to talk about, and it's also perhaps a great attack surface because if everybody's using it, there might be a good chance that you'll find somebody with a vulnerable version of it and be able to attack it. I have seen some changes in the industry where some organizations have either forked OpenSSL or have created their own versions of SSL libraries, whether it's in their language or the same language or different languages, with the idea of perhaps making smaller versions, ones with less features, maybe with less historical support, with the idea of if there's less code and less special cases, perhaps it'll be more of a secure product. Those often have smaller teams working on them or less usage. So I think we'll see OpenSSL with us for many years. I think it's probably going to continue to be one of the most popular open source libraries that are out there. There's a lot of eyes on it, trying to keep it secure and find problems with it, which is always a great thing. But I also think we will see kind of a blooming of what's called open source competitors with smaller footprints or slightly different focuses on what they do to try to keep keep the security level high. And let's see, is there any other questions that are up there? I think there was one more. Okay, let's see if we have one more question here. I think we just answered that. Okay, well, thank you very much for joining us today. Appreciate the questions here and your time as always. If you have any questions or comments, please feel free to follow up with us. We'll have some information in the follow package here on how to follow up with us. And again, as always, please look forward to our next webinar on a topic involving open source and security.
Thank you, Jeff. And just a reminder that today's presentation is being recorded, and we will send you a link to the recording and the slides as the attachment. If we didn't get to any of your questions, we'll make sure we answer you directly. So you still have a few minutes. We'll keep the webinar open, and you can submit those questions. But other than that, I want to thank Jeff very much for his time and the presentation, and thank each of you for joining us today. So thank you, and have a great day.